Dar here, the Shelton guy. This is an overview of pancake die use. It's intended to go with the instruction sheet I send out with new dies. Real briefly, I'll go over the basic concept of pancake dies once again. And that is to create in one thin piece of tool steel the male or punch component and the female. Conventional terms, the female part is called the die, and the male part is called the punch, but we call this whole thing a die, pancake die, blanking die. I use a device that holds a jeweler's saw to cut out the actual designs, and then I use a plasma torch to cut the hinge or flap here. So it's self-contained, self-aligning. This part opens up. Slide your sheet of metal in there, squeeze it in the press, and it cuts out your parts. I set my device with a tilting table at a certain angle so that the saw blade cuts through the steel, leaving a very tight tolerance between the male and female components, and that's so that the die will cut out your parts cleanly. Now these only cut one direction, and they come almost always with the up written on the side of the die, and that just means that goes up and the metal goes underneath it. And they're pre-sprung in that direction, so it's usually very easy to tell which way to load the metal in there. So let me just run a pair of these real quick. So a few things about presses. We're not going to go too far into that. The necessary thing for using these dies is to have smooth, solid surfaces in the press. This is a hardened steel plate. I use sometimes Lexan, maybe aluminum. What you don't want to use is acrylic plexiglass, because that will shatter. Other plastics are more suitable. And the whole point is that the die needs to be supported by smooth, solid surfaces above and below, so that you don't have delicate parts or not supported by the press, by the pressure. If you have a situation where you don't have the whole design covered up, and you have the top surface come down and it's not covering up the whole design, you can very easily break one of these dies. The way I heat treat these, they are softer than conventional dies, but they are still hard enough to break when mistreated, or sometimes when metal gets fatigued from using them so long. Now, you're also not allowed to use hammers on these dies. Some people use vices, just a regular bench vise, but you need to have the jaws of those modified so that the surfaces that contact the die do support the die properly. And for small parts, you can use an arbor press, and those don't come ready for this kind of work, so you need to sort of set those up with other blocks. Again, you can use something, just a small plate of steel, maybe a jeweler's bench block. As long as it covers up the whole design, you're okay. Now, with these hydraulic presses, a lot of work goes on with urethane pads, but you never want to use rubber or urethane with pancake die with cutting a flat part. We will use the urethane pads for forming metal, but never for cutting out a flat part. So another thing to do is to fill up the vertical space in these presses with spacer blocks, so that minimizes the amount of travel that the press has to do. That's just to save time. Now, you can use acrylic for that, but as long as it's not the surface that's in contact with the die. Generally, I use bare metal. Some metal comes with protective plastic film, and sometimes that works, sometimes it causes problems. Generally I take it off one. I do work for a few people where I need to preserve the texture or the polish on the metal, and in that situation, um, one good thing to do is, cheap and easy way to go, is to use blue painter's tape, so that the surface of the die doesn't imprint into the metal. And then in the press, we'll take this steel out, and this is a Lexan block. That's a good surface to have the front of the part being cut, pressed down into. It won't scar the surface of the part. So that's one way to deal with metal where you don't want to mess up the surface at all. It's have to be done very carefully, but it can be done. So let's see here. Like I said, I make my dies tight. That's so they'll cut thin metal cleanly. This is a piece of 30 gauge bronze. Now, because the dies are tight, they won't open by themselves. That's how tight they are. You can hear that click. That's a nice tight die. That's going to cut well for a long time. Now, they don't always open that easily. Sometimes you'll have to take them like this, and this is on my sheet. This is the process that I have a little sketch of. You're taking the die. There's the upside that you operate it from. When it's after you punch it, it's going to be like this. So you want to flip it over. Just take it like this. Grab it by the bottom there. Smack it. That'll open it right back up. And it's ready to go again. Some dies you need to use a little hammer, and if that's the case, you want to hit the actual design itself, not down here on the hinge. That won't accomplish anything. You want to hit it up here, knock it right open. Now, just in case you do manage to get the die loaded the wrong way and press it, you're not going to hurt the die. It won't cut your part out. And it will be stuck in the die. Now, there's the only easy way to get that out of there is to open up that die. What you want to do is open it up the direction that you open it up to put the metal in there. So open that pretty far that way, and that metal will come right out. Some people use this technique when you flatten it out in the press again. And give you a nice little effect there. So, malfunctioning dies, usually that's going to show up as a burr on your part or the part sticking in the die. That happens for one or several reasons. The most common being a misalignment of the die. And what happens is these dies are soft enough so that the metal will actually shift over time. It's not totally rigid. For instance, this whole, and when I heat treat them, they almost always shift. The whole punch here will shift to the left or the right, so I have to realign them before I send them out. So what that does, when they're misaligned, you have looseness on one side of the die, and that allows the metal to either cut sloppily or get stuck in there. Here's a die that works okay on the metal that's intended for. It's pretty loose, actually. It's an old die. It's been used a whole lot. It's stretched out a little bit, so you can see how loose it is right there. Once in a while it gives me problems if I don't load it with enough extra border of metal around that design, but this is a thicker metal, so it's going to behave a little better, and I'll give it plenty of room, so it behaves when it needs to. That's probably 20 gauge copper. It usually cuts 24 gauge. Okay. I'm going to throw a piece of 28 gauge soft brass in there and load it pretty close to the edge there of the design here at the bottom. See what happens. Should stick in there. Sounds like it cut, but yeah, the metal, it can, if it's too close to the edge, it can get pulled in. If the die is loose, it'll allow the metal to pull in instead of cutting. If the die is nice and tight, it will cut thin metal cleanly. That's the way I make them. So this is stuck in here. The way to get it out of there with the least amount of headache is to open the die back up and take the metal out the way it came in, basically. Where'd that hammer go? This one. Open the die back up, and you don't want to try to rip the metal out this way or that way. The point is to try to keep it flat and pull it out the way it came in. Or slide it out that way. I was talking about what happens when parts get stuck in dies and what to do about it. When you have a die that is malfunctioning, if it's simply a case of misalignment, the thing to do is to hammer the base of the hinge here, down here or down here. If you hammer it down here, it's going to move the hole punch over to the left. If you hammer it down here on the left, it's going to move the hole punch over to the right. I'm not going to actually do that, but you know, you set it on a block and you'll peen it. I usually have a actual ball peen hammer for that. And that has to be done very, very carefully, and you have to be really, really sure of what you're doing to make sure that the gap on the left side and the right side here is exactly the same. And you can do that a little bit by feel, but it's good to look at it from different angles, front and back, and feel it. You know, you can tell. Now, that's the best case scenario, is it's just simple misalignment. If it still is giving you trouble, there's looseness that can't be fixed just by realigning it, and this is where it gets messy. It can get messy. This doesn't always work, and it definitely is easy to mess up a die because you start hammering on one part. The point being here is to try to fix some of the looseness. The looseness is what's causing the metal to stick in the die. It's not. It may be because the cutting edges are worn down, but generally that doesn't happen with these very often. So the point is to, instead of trying to sharpen these cutting edges, which is actually the worst thing you can do, it's the wrong thing to do because it's taking metal away from the cutting edge. We want to try to push metal back into this gap, which tightens up that tolerance back more or less where it needs to be. And again, this is very tricky. I don't really recommend this, but what I do is I'll hammer along this cut to try to force metal back in to that gap. I'm not actually doing this, but that's what it looks like. Now, there's always a action and reaction. You can't ever, it never happens where you hit it and the metal only responds by moving in one direction. It's like you hit it over here and it moves something else the other way, so it can get very messy that way. It generally works pretty well on real simple designs. Any kind of complex designs, it can get pretty ugly pretty quick. Actually, that's just about it for the basic stuff. Could go into things a lot deeper, but that's not really the point of this little demo here. So once again, thank you very much. See you next time.